Good morning, Horace.
It's hard.
Yeah, that's uh, been a common description of that exam, yes. Um, I think it had more to do with it was just brand new subject matter. It wasn't things that you had normally studied in the past or considered for. So it wasn't that it was hard to understand, it was just that it was that new to you.
Good afternoon.
Hello, Christine.
How are you doing?
Well, my one day off, I've got lots of errands to run. And then I'm going to try to make some me time later tonight. So,
Oh, that's awesome. We all need that me time.
oh boy. Yeah, I'm in need of it lately. So yeah, I'm going to just hang out in my backyard and decompress.
Oh, that's what we do. We hang out in our backyard. We love sitting outside and just drinking some iced tea or something, you know?
More like something for me.
Yeah, or something. Yeah, or something.
But yeah, you had mentioned that you had one earlier, but yeah, I have my telescope set out in the back, so I just randomly observe.
Yeah, I was on Facebook. There was we were looking at Jupiter last year today, and the pictures of us looking at that with our telescope in the backyard a year ago today. And then I read an article too. What is up with the sun flare, something that's supposed to hit the earth or something, the heat, I don't magnetize, whatever thing?
Well, you see, periodically the sun, I don't know how to describe it other than to say it like burps, and it spits out into space whole chunks of matter that are greater than the size of the earth many times, and it just spits it out into space. And it's going to light up our magnetic field as it comes into contact with it. Some of the energy will no doubt make its way to the surface, but fortunately not a lot of it. But yeah, it'll light up the magnetic field. You might even possibly see an aurora borealis extending a little further south than normal.
Okay. Yeah, I was talking to my mom about it, and the article that I was reading last night said that it might kind of interfere with our cellular devices a little bit, and I'm not sure.
It's a possibility because you'd be surprised at how closely associated the electronics that you personally possess, how closely associated they are with Earth's magnetic field. How else do you think your GPS and your phone works?
Oh, right. Yeah, definitely.
So there's a possibility that it could interfere with communications on this planet. Yeah.
Yeah, I was letting my mom know because she lives alone, and we live in Hanford and she lives in Lemoore. So, I mean, it's only about 10-minute drive or so, but with her age and her health, I'm like, okay, well, hopefully if it does mess with anything, it won't be too long. And I'll be able to call, because I check on her several times a day. So,
right.
Yeah.
Well, fortunately, at least in our lifetime, Earth has never been, directly head on in the way of one of these things. uh, to my knowledge, the few times that it's happened here on Earth, it had to do with this. They call it, the name for this is called a coronal mass ejection.
Mm-hmm.
And so they refer to it as a CME, coronal mass ejection. And they've happened plenty of times, but when it comes to the Earth, fortunately, it's only come close a couple of times, and we've been grazed by it, you might say. But in my lifetime, I'm not aware that we've been like in the middle of the bullseye zone. No.
Yeah.
So I don't know the extent of the impact that's going to happen, because if we're in the middle of it, then yeah, you're going to see a lot of fireworks. But if we get some grazing pass by, in some places on the Earth, you may not even notice it at all.
Right.
Mm-hmm.
Probably depends on where you are on the Earth when it hits the
now think about this. Suppose you're an astronaut orbiting in the space station.
Oh, I know. I was talking to one of my girlfriends earlier. She called me because she's excited. She's asked me if she could use me as a reference on her application. And so I was telling her about it, and I said, we have all those satellites and everything out in outer space, and they don't have the protection that we do with our atmosphere, and they're just kind of hanging out there. So
you're exactly right. That's true. Our satellites are very vulnerable to that kind of solar activity. It's also it's what is slowing us down in regards to building a manned base on the moon. We've had ambitions to do that now for the last couple of decades. And the rocket technology to get there is not the problem. It's, how do you set up a habitat on the moon, because you have no protection from the sun. And so they've spent the last couple of decades with the satellites. What they've been doing is trying to create as accurate as possible a topographic map of the moon and as much of the geology as they can possibly determine, because what they're looking for are underground caverns that were carved out by basically lava. Now there's no activity inside the moon anymore, but at one time the interior of the moon was molten, and so there are tunnels that they've discovered, and this is where they think they might want to build one of these moon bases, is in this tunnel.
That's interesting. Wow. So really silly question. Is it hot or cold in space?
It's pretty darn cold.
Okay.
The problem, the misconception that people have about temperature and whatnot, keep in mind temperature is a measure of molecular motion.
Right.
Okay, it's not a measure of heat. And so when you're in the vacuum of space, there's no molecular motion, is there?
Mm-mm.
So there's nothing to convey heat onto your body. The only reason you feel heat is because you're surrounded by oxygen and nitrogen molecules.
Right.
So what you're feeling is the hot air interacting with the pain receptors on your skin. If you're in a vacuum, and remember from previous exam, infrared is the frequency that you perceive as heat.
Right.
And so if there's no molecules to transfer that heat to the surface of your skin, that energy waveform is going to pass through your skin. It's going to strike and be absorbed by the soft tissue inside your body. So the first sensation of heat that you're going to have as you're floating in outer space is from the interior, not the exterior. You're going to feel your insides getting really, really hot.
Mm-hmm.
And then eventually it's not a pretty scene after that.
I was just curious because, there is no protection out there. So, but
You know
all
what?
of the,
Sound waves are just another form of electromagnetic energy. They're just a different version of visible light, heat, ultraviolet, and whatnot. So you're aware of the fact that the only reason you hear sound is because of the fact that you're in an atmosphere. The air that you are breathing conveys sound waves.
mm-hmm.
Okay, if you and I were in a vacuum, besides not being able to breathe, we wouldn't be able to talk to each other. There would be nothing
Right.
to carry the sound of my voice to. Well, light and everything else behaves the same way. It would move through space, yes, but once it strikes you, you'd have no sensation that anything is striking you because there's nothing to convey that. So it would penetrate your body and unfortunately do its harm in that fashion. But the vacuum of space is not quite exactly, it's about 3 degrees above absolute zero. That's the vacuum of space. So the dust cloud that eventually became our solar system started off as a really, really, really cold cloud of hydrogen gas. And most of that ended up in the sun. But it started out as temperatures near absolute zero. And then as it all started to compress, then the temperatures went up. And eventually the temperatures got hot enough in the middle of that cloud, boom, nuclear fusion occurs.
Yeah. Interesting. Yeah, I always wondered if it was hot or cold because, there's all the sun and the stars and everything's hot, but it just kind of just disperses out, I guess, just doesn't go.
Well, it is putting radiation out into space. The problem is you just don't perceive it.
Mm-hmm.
That's the danger.
Yeah.
Until it's too late. And then you realize something's wrong, but by that time it's too late. But yeah, that was the genius of Mr. Einstein, by the way, the movement of this energy through space, because up until the year 1905, science was aware of the speed of light. They knew how fast it was. That had already been measured.
Mm-hmm.
What they didn't know was light from a faraway star. How did it get to the Earth? And they speculated that the principle of how it got from that faraway star to the Earth was similar to you dropping a stone in a pond and then having the wave, the ripple, extend outward. That's what they thought that the universe was made up of an invisible substance that they called the ether. And they believed that is what propagated light waves across space. They didn't believe that light could move through a vacuum. And it was Einstein that figured out, no, you guys have it all wrong. There is no such thing as an ether. There's just the vacuum of space. so up until 1905, yeah, the universe was a huge mystery to us. And so here we are in 2021, it's barely 115 years later. And look how much we've learned, and yet how much more we still have to learn.
Right.
This is part of the reason why I'm so fascinated by this subject as a hobby, Um, to me, that represents, from a purely philosophical viewpoint, everybody, we are, you might say, children of this universe. And all the forces that came together to create this solar system and this earth and whatnot, that basically makes you, me, and every living thing on this planet what do you call it? We are the universe's self-awareness. We are of this universe, and we have the ability to look at it and study it and get to know it and understand it. So far that we know, there's no other species in the universe that has that ability. Now, we may discover other species, but so far we're it. And so we are the universe's version of self-awareness. And so that's personally how I kind of see that we're all connected. Okay, let me get the study guide. All right, let me get this going here.
Recording in progress.
Hello, everybody. Good news. I got all of your exams, and I've actually got them graded. So there's only 8 of you here right now. So before I finish, and I'll turn off the recording, but if you want to know your grade right now and you don't mind other people hearing it, I'll give you your grade here over the Zoom. Otherwise, it'll be this afternoon when I start emailing everybody with their grade. The grades were only just slightly lower than the first exam, but overall, I think the vast majority of you passed. I think there was only one person that got in the 60s, and that was it. Everybody else passed and did fine. But I think in many of your cases, your point total was just a little lower than your first exam. Otherwise, you did okay. All right. So if you want to email, or if you want me to give you, after we finish here, if you want me to give you your grade, I've got them all done already, okay? So exam 3, some comments first off about exam 3, everybody. Yes, it's the final exam for this class. And the big question I'm going to answer right now, no. It's not comprehensive. It's merely exam number 3. Okay? So no need to pull out all the old notes. Okay? In the first exam material, you received information regarding some of the basics about how we view the Earth and how we measure the Earth in latitude and longitude and so on and so forth. And then on the second exam, it was all these naturally occurring forces that work to create the various ecosystems on Earth. And so I was basically explaining all of those naturally occurring processes that occur on top of the Earth, that create weather, that eventually create the various ecosystems on Earth. There is also a generalized pattern to it. I went over that, so on and so forth. This set of this exam 3 material has to do with all of the naturally occurring forces inside the Earth, okay? And this essentially means volcanism and plate tectonics, okay? earthquakes, volcanic activity, that kind of thing. So in exam 2, it was everything on top of the earth. Now on exam 3, it's everything inside the earth. There is a bit of a balance between the two forces. In exam 2 material, it was basically the weathering process, and that acts to wear the surface of the earth down. When it rains on this earth, everybody, and it creates lakes and rivers, okay? Not quite every single one of them, but the vast majority, like greater than 90% of all the large rivers on this planet, empty out into an ocean somewhere. Okay, there's a couple of exceptions, but for the most part, they empty out into an ocean or a large body of water. The Mississippi empties out into the Gulf of Mexico. The Rhine River empties out into the Atlantic. And the Amazon empties out into the Atlantic. And then, of course, there's all the rivers in Siberia that many of you have never heard of before. These rivers are absolutely huge, everybody. They're the size of the Amazon, and there's several of them in Siberia, and they all empty out into the Arctic waters of the Arctic Ocean. Okay, so the action of these rivers is to wear down the mountains. They carry the dirt and the debris from the top of the mountain down to the lowest point, which is sea level, okay? And so that's how they wear the earth down. In exam 3 material, all of the processes, volcanism and plate tectonics, eventually work to create new earth material. So there's the balance, everybody. You've got processes that want to wear it down, and then you have processes that want to build it back up again. And volcanism and plate tectonics are going to build it back up again, okay? In the beginning of this section of material, once again, it looks highly scientific, like, oh my gosh, what the heck are we getting into here? It's another one of those sections, everybody, where I'm going to give you some explanation of it, but it's not going to generate a whole lot of questions on exam 3. So I don't want you to stress over that section about atomic structure, okay? But in understanding how things came to be on this earth, it helps to understand a little bit about how atoms come together to form minerals. Okay. One of the PDF files that I sent you is the table of the chemical table, periodic table of elements. No, I am not going to require you to memorize that for the sake of the exam. That is given to you for reference material only. Okay. So there are 92 naturally occurring elements inside the earth. Anything over the number 92, so from 93 up, no matter how high, those elements are man-made. Okay. They're not found in large quantities because they're man-made, and many of them, as soon as scientists put them together in a lab, they don't last very long. They tend to fall apart rather quickly. So that's why you don't see any of these elements, in a Target store or a Best Buy. They don't last very long. However, we're aware of their existence. We're aware of their properties. So they're documented on the chemical periodic table, okay? They do, in fact, exist, okay, but not in large quantities. But the only ones found inside the earth naturally are those first 92, okay? So if you wanted to play the creator and create yourself an earth, and you needed a set of ingredients, you would use the chemical periodic table, because that's basically what Earth is made up of, those elements, okay? You're going to find out later in the lecture that of those 92 naturally occurring elements that inside the earth, everybody, about 8 of them make up most of the earth. The remaining 84 elements are found in trace quantities. So that should give you some idea of just how rare gold is. Okay. Relative to the volume of the earth, gold is a statistical blip. It barely exists. So the single most common element inside the earth is probably not one you would readily guess. Most of you would probably come up with some metal or something, and that's not it. The single most common element inside the earth, everybody, is oxygen. The second most common element in the earth is silicon. Those two elements frequently join together to create a mineral. So what do you suppose the most common mineral inside the earth is? Quartz, because that's what silicon oxide is, quartz. So the earth is, it's a rock on the interior. Yes, it's a rock, but the most common elements are oxygen and silicon. Just those two elements alone, everybody, make up 2/3 of the interior of Earth. The volcanic activity that occurs on this planet, volcanoes actually not only have a purpose, everybody, but there is a rhyme and a reason as to where they are located. Okay, they're not random. There's only one exception to the rule, and I'll explain it later, but it has to do with the Hawaiian Islands. But volcanoes, for the most part, are located in these particular areas for a specific reason, okay? There's a classification of volcanoes that we will go over in this section of material, and it has to do with which ones are the most violent as opposed to which ones are the quietest, the ones that don't make a lot of noise, and they just basically belch out a little bit of lava from here and, from time to time. What are the difference in these volcanoes? As far as volcanic activity is concerned, there are 2 known hotspots of volcanic activity. Earth, so far that we've been able to identify everyone, Earth has about 2,000 volcanoes on it. And you should thank your lucky stars that about 1,500 of them are under our oceans. There's only about 500 of them on the surface of Earth. Much of the rest of them are under the oceans. And one of the functions of a volcano, if you think about it, everybody, the core of the earth is molten. There's a lot of heat in the interior of the earth, and it has to escape eventually. It has to. It's like the heat on the interior of your body. If it gets too hot, you have to get rid of it. So how do you do that? On your body, you get rid of heat through the pores of your skin. You not only sweat, but you radiate heat. Well, this is kind of the function that volcanoes perform on Earth. They vent heat from the interior of the Earth. And in the process, they produce all of this magma, which is basically new Earth material. The 2 hot spots for volcanic activity on the surface of Earth, one of them, unfortunately, is located in the Caribbean and the Gulf of Mexico. Um, South America is migrating in a northward direction, and it's literally crashing into the southern end of the North American continent. So far, that collision has created all of the islands in the Bahamas and the Caribbean. It has created Central America. You see, geologically speaking, North America extends all the way down into the southern Mexico in a region called the Chiapas region. That's where North America geologically comes to an end. Everything between the Chiapas region of southern Mexico and Venezuela is brand new territory. Panama, Costa Rica, Honduras, Guatemala. This is brand new land as far as the geologic history of Earth is concerned. And it's the result of a collision between South America and North America. So some of these volcanoes that are located on these cute little Caribbean islands are some of the nastiest ones on Earth. If they blow, you really don't want to be around one of these things. And as the Mexicans would have the luck, everybody, the country of Mexico has 3 of these volcanoes. And as chance would have it, all 3 of them are within eyesight of Mexico City. Many of you are already familiar or aware of the fact that Mexico City is sitting on top of a swamp. And so what happens to the ground when an earthquake hits? That swamp turns to jelly, and everything that's sitting on top of it either is destroyed or it sinks into the ground. And then you've got 3 of the nastiest volcanoes in the Western Hemisphere, located right outside your back door. The Mexico City population and the surrounding metropolitan area, there are more Mexican citizens living in and around Mexico City than there are Canadians. And you want to evacuate all of these people? Anyway, in the Eastern Hemisphere, something similar is happening. Australia is migrating in a northward direction, and it is going to eventually collide with Southeast Asia. It's going to hit the coast of Vietnam and parts of southern China sometime in the distant future. But the collision has already begun. It has created the country of Indonesia, Papua New Guinea, and all of those little islands just north of Australia, the Solomon Islands, parts of the Philippine archipelago. These are all a result of this collision. And these volcanoes are of the violent type, just like they are in the Caribbean and Mexico. They're violent. When they explode, they're very destructive. They throw a lot of debris out into the sky, lots of magma. And to give you some idea of how powerful these volcanoes are, many of them, when they do explode, they will remove as much as 8,000 to 10,000 feet off the top of the mountain. That's a lot of dirt. And they're going to move it like it's nothing. So these are very powerful eruptions. The most famous eruption took place in Indonesia in 1883. The volcano known as Krakatoa exploded, and it virtually killed the entire population of that island, and I believe it was around 30,000. And something rather curious, if you were to ever look up American newspapers from that particular date, eyewitnesses in New York City claim to have heard the eruption. So that was big. And then, of course, many of you historians in the class might be familiar with Santorini. It's a Greek volcano. And for those of you who are interested in biblical history, they believe that the volcano erupted right about the time Moses was conducting the Exodus. You know that part about raining frogs and all of that, you know, all the tortures that the Egyptians had to suffer because of their persecution of Moses. Well, they're beginning to make a link to this volcanic eruption. But anyway, plate tectonics has to do with earthquakes, the movement of the plates of the earth. The crust of the earth, which is the uppermost layer, it's the one you are standing on right now. It's cracked like an eggshell. And one of these cracks is located here in California. It's the San Andreas Fault, everybody. The coast of California is moving in a northward direction. The rest of California, and that's you and me, is moving in a southward direction. And according to computer models, this will give you some idea of how quickly it's moving. Los Angeles is going to be up around San Francisco in about 50 million years, provided nothing else happens. The fault lines that are located all over this earth, and I'll explain this later, come in three categories, and it's based on how they move. Okay, so in the case of the California fault line, the two sides of the fault line are basically sliding past each other. They're not colliding with each other, and they're not moving away from each other. They're sliding past each other. But just because they're sliding past each other doesn't mean that they're any more or less dangerous than a plate boundary that is colliding with each other. The boundary between South and North America is colliding with each other, and it created those volcanoes. In the case of California, we're sliding past each other. But the energies involved in moving whole continents I mean, nuclear weapons pale in comparison for how much energy it takes to move a continent. Did everybody feel the earthquake a couple of days ago? I was told that it measured 5.9 on the Richter scale. I actually felt it in my house. I felt the floor of my house move. It rolled. And did anybody else feel that?
We did.
Yeah, it was a pretty eerie feeling, you know, to feel the ground move like that. But anyway, when the San Andreas fault line, as it's been moving over the last several millions of years, over these millions of years, everybody, it has released enough energy that it has literally squeezed the Sierra Nevada mountains up out of the ground. The Sierra Nevadas are not volcanic. They formed completely, entirely from one end to the other beneath the surface of Earth. They were popped up like a big, huge pimple by the San Andreas fault line. The Sierras only extend just a little bit past the Sacramento area. if you ever drive to Northern California, everybody, as you get close to the Oregon border, the mountain range that is on the right-hand side of the highway is no longer the Sierra Nevadas, it's the Cascade Mountain Range. And California is the southern end of that mountain range. It extends all the way up into Canada, into Alaska. This mountain range is volcanic. And so when you drive to Northern California, if you've never been up there before, everybody, the landscape has a noticeably different appearance to it, because here in the Central Valley, we've got these desert tones and desert hues. Everything looks beige down here. We're noticeably drier. It looks like a desert. You go up to Northern California and you see nothing but redwoods. You see lots of grass, lots of natural grass out on the side of the highway. It's a lot taller than you see it here in the Central Valley, and it's a little bit greener than you see it here in the Central Valley. And the soil is not beige, it's volcanic soil. So it's nearly black in appearance. So Northern California has a noticeably different look to it than Southern California does. And it has to do with the fact that California has 2 active volcanoes. They're on the southern end of that Cascade Mountain Range, which happens to be in California. And these 2 volcanoes are Mount Lassen and Mount Shasta. According to the geologic evidence, Mount Shasta has a history of erupting every 250 to 300 years. The last reported eruption of that volcano was in the 1750s. Do the math. The other one, Mount Lassen, it last erupted in 1921. And created quite a mess. I don't know how many of you are old enough to remember this, but in March of 1980, this volcano, it's in the Cascade Mountain Range, but it sat on the border between Oregon and Washington, and it was called Mount St. Helen. And it erupted in March of 1980. I'm just trying to give you an idea of how powerful these local volcanoes are. For those of you who had family living in Visalia in March of 1980, you were shoveling ash off the street in front of your house. That's how powerful that volcano's eruption was. It blew off about 6,000 of the feet of the mountain, created this absolutely huge crater. But the smoke plume that it created was about 20 miles high. And the ash cloud that it dispersed literally covered the Northwest United States. So yeah, you were shoveling ash off of Lacey Boulevard and Mooney Boulevard at the same time. And it was thick. Look at news photographs from that time period. And we're not talking about a sprinkling of dust here. We're talking about full on knee deep in ash. Anyway, so this section of material has to do with all the naturally occurring processes that occur inside the earth. The first section of material that I'm going to pick up with tomorrow has to do with atomic structure. Once again, don't be overly concerned about this. I'm not going to ask you to suddenly go and study the atom, okay? I merely want to explain some things to you about how minerals come to be, because minerals are the collection of different atoms that stick together. And the example I gave you earlier was silicon and oxygen. When they combine, they create quartz, okay? So I wanted to give you a little bit of background of just how it is they do that, because there's a reason why some elements like to join with each other and others don't, okay? And there's a reason for that. So a little bit of background information. There's only going to be 1 or 2 questions on this particular section of material, and I will point them out to you, okay? So that section about atomic structure, once again, is mostly informative, explanatory type material, and the little bit of subject matter that shows up on the exam, I will point that out to you, okay? So anyway, I'm going to stop the recording now, and for those of you that want your grade over the Zoom here, I will give it to you.
Recording stopped.
Are you gonna go over the actual exam to look at what we did or no?
I might do that tomorrow. Yeah, I have a meeting I have to be at here in about half an hour. So if you want, do you want your grade now, Veronica?
Yeah, I want to know. I was kind of stuck on a couple of questions. So I wasn't sure if I got them right or not.
Well, you got a 92 on this test.
Okay, nice.
Mm-hmm.
Okay.
Yeah, I may go over it tomorrow.
Okay, so I can see which ones I got wrong. Okay.
Okay.
Awesome. Thank you so much.
Sure. Anybody else?
I'll take mine, Christine.
Okay, let's see. Christine, 92, dear.
92. Okay.
Yeah.
Oh, I was going to say too, I lived in Susanville, and there's
Uh-huh.
Mount Lassen that's there.
Uh-huh.
And you can actually see from Susanville, you could actually see the side of the mountain where the volcano blew out the side of it. And there
Uh-huh.
literally is a crater that's still on the side of the mountain.
That Lassen, you mean?
Yeah, Lassen. Uh-huh.
You know what I like is that trail that takes you up to the top.
Mm-hmm.
Every like 200 or 300 yards, there's a small podium on the trail, and there's a plaque on the podium, and it tells the story of these 3 guys who in 1914, when the volcano first began erupting, they were elected by the city elders to go up the side of the mountain and find out what the hell was going on, because nobody had ever seen this volcano erupt before.
Uh-huh.
So they sent, and it's the story of these 3 guys that go up the side of the mountain, because when they got to the top, it erupted and they all survived. And it's the story of these guys. It's interesting. You walk every couple of 100 yards and it's like there's another paragraph to the story. So it's kind of like an incentive to keep going all the way to the top.
Yeah, I never walked it. I lived in Susanville for about 5 years. I actually went to Lassen Community College up there. But yeah, I thought that was pretty interesting whenever you said Lassen. I was like, oh yeah. And then we went up to Chico and stuff. So we saw all the,
It's very kid friendly, that park.
Yeah. But all right, I'm going to take off. My kid's getting crazy for whatever reason. So I got to go figure that out.
Tomorrow.
All right. Thank you.
Bye. Did anybody
Bye.
else want their grade? Okay, Jack. Jack, you got a 92. Sure. Okay. Yeah, I'll go over the test tomorrow. All right. Anybody else?
Yes.
Oh, Horace, come on, have more faith in yourself. You got a 74, Horace.
All right. Thanks.
I'll take mine.
Brianna, let's see, 78, Brianna.
Thank you.
Okay. Any last takers here? Jesse, you want yours? Oh, all right. I'll see you guys tomorrow.